Wee. 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 I bet it's dizzying living on that planet. Hello world and welcome to Super Planet Crash. Woo! See this solar system? This here is my solar system, and I guess that means I own that planet. Probably explains why it's a little bit wonky. Yes, some idiots put me in charge of an entire solar system, and I can do all kinds of interesting things with it, like add planets. Whoa, yeah, look at me go. And yeah, okay, so the basic aim is get as many planets in the solar system as possible. Oh, there you go, I lost already. Yeah, I have to get as many planets in the solar system as possible and maintain them in stable orbits. And alright, if they go outside this line, as this blue one up here has, I fucking lose. Don't like losing. But yeah, the longer I keep them in, the more points I get. Especially if I'm in this zone here. This is the habitable zone. You get bonus points for doing that. And the bigger the planet, the more points you get as well. Because the bigger the planet, the more of a gravitational force it exerts. I'll demonstrate. Let's go for Kepler 11. There you go. Wow, look at this go. Okay, so I'm clearly not going to get anything in this habitable zone. Look at all these planets going nuts. But let me demonstrate what happens when I place an Earth. Not a whole lot. Keep going, keep going. Yeah, and look, I'm accruing points as time goes by. But watch what happens when I place a dwarf star. Let's put it right on the outside here. Boop. Look at what that does to the orbits. Bloody hell. That completely screws things up. I mean, even the star in the middle is moving around. Good grief. But yeah, so the more of these I can... Oh, there you go. Can't pull it down. The more of these I place, the more points I get. I only manage it for 1.3 years. Anyway, yeah, so we're... Excuse me. Bloody hell, slow down. Slow down a bit. So we're gonna try and see what we can do. See if I can win this. I don't know if there is a winning. Let's see if I can get 10,000 points. I'll do. Oh no, okay, maybe not. Oh, I got 20,000. How do I manage that? Oh, you get 30,000 just for placing it. Okay, that seems a bit unreasonable. Let's see if we can get 1,000,000 points. Think about 1,000,000 points. There we go. That looks like, well, call that Venus. Let's place an Earth here. Boop. There we go. I'm getting a crap ton of points for doing that. Another one there. There we go. Whee, look at that. Red, blue, and green. I got all the primary colours covered. Boop. 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 I think I can place, what is it, up to 11? No, 12, look, up to 12 bodies. 12 bodies in my solar system. But yeah, this is fascinating because if you leave it going long enough, you can build up orbital resonances, which is fascinating. Fascinating for physics, quirk of physics, I should say. Where basically the gravitational effects are compounded by objects that orbit, say one in here orbits twice for every time one orbits out here. So they're regularly lining up. That'll mean that they affect each other more strongly. Because there's a regular point where they're, well, closest approach. There you go. These orbits, this gravitational pulls and the orbital resonances within this are clearly having some sort of effect. Now if I really want to screw it up, boop. Oh no, that didn't work. Helps if I select a dwarf star. No! Oh well. Oh dear. So yeah, stable orbits inside the habitable zone get me more points, which is nice. As you can see, I'm accruing quite a few. Ooh. Earth doesn't get me a lot. I should have gone for some bigger ones, shouldn't I? Should we start over? Yeah, let's start over. Thank you for that. New game! Oh wow, that's different. Let me just place them randomly. So let's try placing a brown dwarf. So a brown dwarf would be a planet... Well, planet that's almost big enough to be a star. We're talking like many, many times the size of Jupiter. There we go. A failed star. Something of stellar mass that hasn't quite achieved... No, isn't quite big enough to have achieved fusion. Wow, that's going nuts. Slow down a little bit if you would, please. Okay, let's... Excuse me again. So we could place one here, really close to this star. That's going to balls this up. So we'll place it out at 2 AU. If you don't know what an AU is, it's an astronomical unit. 1 astronomical unit is the distance between the Earth and the Sun. So 2 AU is about... Well, it's twice the distance from the Earth to the Sun. It's a little bit beyond Mars orbit, I think, if I'm remembering the numbers off the top of my head. I think Mars is at like 1.5 AU and Jupiter's at like 5. Something like that. Can I remember these details off the top of my head because I'm useless? Right, let's place a brown dwarf really close. That'd be what is known as a hot Jupiter. Very hot Jupiter. Man. So yeah, Earth would be, well, an Earth. Super Earth, super large terrestrial planet. See how that goes. Ice giant would be like Neptune, Uranus. Because a lot, I know they're often called gas giants, but there's a lot of things like ammonia and methane ice in them, and it means ice giant just makes more sense than gas giant when most of it's liquid and crystals and ices and stuff. Yeah, I know. A gas planet would be like Jupiter and Saturn. Saturn's fascinating. Saturn is less dense than water, which means if you could get a body of water large enough, it would float. Fun fact of the day. That is going nuts. Slow it down a little bit. Or should we go really quick? Let's just go. Wow. It's like a spirograph, isn't it? Look at it go. Yeah, so we're almost 70 years in, so let's slow down a little bit and place some of these. There we are. Okay, we have some brown dwarfs. Excuse me. Oh, that's going. Is that going out? Ooh, don't go out of the solar system. So yeah, this is going to accrue at some points, but ooh, no. Okay, so it's messing with this one. Ooh. Right. I don't think this is going to end well. I think. Oh God. Yeah, there we go. It's hard to get the bigger ones in stable orbits, which is why they're worth more. Get Super Earth into a stable orbit. There we go. Let's place a few of these. There. Oh, didn't mean to do that. I meant to put it there. There we go. See, now at least we have 8 stable bodies. Nothing quite like having a stable body. Okay, let's try an ice giant really close in. Oh, good grief. Ice giant learned me quite, 15 times the points that an Earth will. And I don't think it affects a large enough gravitational pull to affect all these out here too much. Which is nice. I don't think we're going to get a million points doing it that way, though. I mean, brown dwarf is ridiculous. Look at that. Balls that up. That's going out. There we go. Wow. Okay, so let's go for a template. That one? Oh, no. I want one with very minimal. Yeah, that'd be alright, won't it? If I place a brown dwarf as far away as I can when that's at its furthest extent. See what kind of orbital resonance that falls into. Yeah, let's place it there. There we go. Oh, no. I meant to place that in the habitable zone. Failed miserably. Okay, let's speed things up a little bit. See how that affects things. Yeah, the sun's moving, so it's clearly going to affect that. Ooh, no. Well, that would be an interesting quirk in your orbit, wouldn't it? Imagine if the Earth did that. What if you'd feel it? Let's try this again. Okay, let's place a gas giant in the habitable zone. It's a sensible place to put a gas giant, if you ask me. That's how you get interesting habitable moons, like in sci-fi, like Pandora, for example. What was the movie called? Avatar, that's the one. It took me a minute to search for that name in my head. Brain isn't working, but yeah, I hear they're making another Avatar movie. That'd be great. This is going to get ballsed up when that catches up. Yeah, look at that. Pulled it into a wider orbit. Much more eccentric one as well. See, our sun's habitable zone pretty much extends all the way from Venus to Mars. That means that an Earth-like planet, placed in any orbit between Venus and Mars, more or less, would still be capable of hosting life as we know it. Which I find fascinating. I mean, out near Mars gets about half the solar energy that we do, which is an issue. I mean, it'd be a lot colder. And Venus gets quite a bit more. But life could still exist. It wouldn't be as comfortable and pleasant as it is now. But, it's still fascinating to think about, because it means, the scope for where Earth-like planets could be, and you still get life on them, it's just enormous. And I love stuff like that. I mean, who doesn't love sci-fi? Boring people don't like sci-fi. Bloody hell, look at what that's done now. I should be placing more, shouldn't I? Let's place a few out here. Well out of the way. There we are. They might start affecting each other, but we can live with that. It's this interaction that's intriguing me. Look at that go. Ooh. Every time they get close, it completely rearranges the green one's orbit. Which, you know, you'd expect, because it's fairly substantial. I mean, oh, there we go. That we didn't want, but we got 100,000 points. Yeah, we're doing well. Let's give it another go. We'll go for that one again. Let's put a brown... No, let's just go for a gas giant here. This should be interesting. Because they're both gas giants, aren't they? Right, and then we can put an Earth out in the habitable zone. I mean, this is the other thing. The bigger and brighter the star, the further out the habitable zone is. But the issue you get is you're unlikely to find life around certain types of stars because, you know, your big blue supergiants and, well, pretty much everything up to a Class F white star, which is only marginally hotter than our own sun, they just don't live long enough for life to evolve. I mean, the big blue giants live for tens of millions of years. Now, it took... excuse me. It's taken billions of years for life to get to the point it is at on Earth. So, for life to evolve in any substantial form, you probably need billions of years, which means you need stars that are going to live that long. And as it... No, there we go. And as it turns out, stars that are going to live that long, at the very least, are sun-like stars. Makes sense. I mean, that's what we see, you know. If something takes a long time to evolve, you need it to be on a planet that has a stable orbit around a stable star for a very, very long period of time. You just don't get that around big stars, because these big ones will go supernova sooner rather than later. So, I mean, you know, sun-like stars are ideal for it. And to a certain point, you know, the orange stars, like, you know, the Class K ones that are a similar scale to the sun. We're not talking the supergiants or the orange or red giants, because they're not going to be stable long enough anyway. That's just not worth it. But the ones that are more sun sort of size and smaller, I mean, they're dimmer, but they burn longer, which means you've got plenty of time. I mean, the sun, that kind of sun requires the planet to be much closer, and there comes a point with red dwarfs where the planet has to be so close to the sun that it actually becomes detrimental, you know, that it becomes tidally locked, or it becomes so close that issues with the star's stability can pose more of a problem. So it turns out, you know, Class G, K and M stars of a certain size and scale, they're ideal for it. So those are the ones you want to look at for life. I mean, you still get planets around these other stars that are less ideal for. I mean, you're going to get a planet around any star that exists for a few million years, because it only takes a few million years for a planet to form from the dust and stuff. But yeah, if you want anything, if you want complex chemistry to form, you need something that's got far longer lifespan. I mean, it's no good thinking, oh yeah, let's get life going on this planet, and then suddenly your star goes supernova. That'll really ruin your day. But at the same time, you don't want it around a star that suddenly becomes a giant, you know. I mean, the sun has 10 billion years as a yellow star. Then it'll become a red dwarf, and that's what you want. But for a slightly hotter star like a Class F star, you know, the ones that are properly white, you know, their lifespan's like a tenth of the sun's. It's a billion years. That's not long. It's not long at all. Whereas these little red ones, a little red dwarf, that can live for trillions of years. So that's plenty of time. You know, they can be stable for trillions of years, in theory. In theory. So life around one of those could live for a very long time. So say, you know, you got like a star that's a red dwarf that's, say, a quarter the size of the sun. Your planet would need to be in like a Mercury-like orbit to even be remotely habitable. But it'd be doable. It'd be fun, it'd be interesting. I mean, life that evolves on that's going to be different as well, because stars of that nature have a different peak wavelength of light. I mean, the peak wavelength of our sun falls in the green part of the spectrum, in the visible part of the spectrum. It's probably why visible light is visible to us. It's why photosynthesis uses that particular band of the spectrum. But you go down the scale through the orange and the red stars peak in the infrared. So you get plant life on a planet around a Class M star. chances are it's going to look absolutely beautifully deep pitch black, well, really deep blood red, pitch black. This is going to be fascinating. You're going to get a whole new type of photosynthesis happening. And likewise, if you go up the scale a little bit, I mean, Class F stars, their peak wavelength is in isn't too far above our own suns. But beyond that, when you start getting to the blue stars, it starts peaking in ultraviolet, or you even get one that peaks in the X-rays sort of range. That's going to sterilise your planet. So again, that's another argument, another good reason why you're probably not going to find life there. And I'm really rambling about this, aren't I? But, it's good having a topic you're passionate about. And, well, as you can see, we're doing really well. I mean, I'm going to speed this up. Wow, okay, you cannot see what's happening there. But yeah, I've done well. I've got 12 planets in a relatively stable orbit, and we're accruing points. I mean, oh, there you go. Things are starting to get a bit funky. See, this is what happens. Resonances pull things into weird orbits. And you do get resonances in the solar system that clear entire swathes of it. I mean, you look at, you want an example, look at Saturn's rings. There's orbital resonances between parts of Saturn's rings and its moons. I mean, the rings have gaps in them. Those bands that you see, there are gaps in them where material has been pulled out into certain regions in orbit around Saturn because of the pull of its moons. And you find these orbital resonances, ones where it's like for every one orbit there's 2, and for every 3 orbits there's 2, and 4 to 1, and stuff like that. And there you go, we've got points. And yet, you find that on that scale, you find it on the scale of the solar system. And I wouldn't be surprised if you found it on a sort of almost galactic scale, to a point. I mean, you do in a way, because you get the compression waves that go around the galaxies, and they make it look like the spiral arms. The stellar density of the galaxy is pretty uniform, but you look at it, the spiral arms are actually waves of star formation travelling around the galaxy. And that's caused by pressure waves, which have to have something to do with orbital resonance. But yeah, I'm rambling now anyway, yeah. So yeah, this has been a Super Planet Crash. I hope you've enjoyed it. I mean, we haven't actually crashed any planets. We've flung a few out into distant orbits. It'd be nice if you could make this gap a bit further, make 0.15 AU. If I could set that as, say, Jupiter orbit, and zoom out, that'd be fascinating, wouldn't it? But yeah, I hope you've enjoyed me rambling about this. I mean, I love games like this, just little things where you can play around with physics. Physics games are the bomb. I know. Yeah, thanks for watching, guys, anyway. I'll see you next time. Ta-ra! If you enjoy my efforts to be vaguely entertaining, you can now support me on Patreon. $1, a pound, a yen, a euro, whatever you've got, whatever you can spare, all helps. Over 1 million fed. Thank you for watching, and ta-ra!